Okay, now let's talk about ionic bonding. Ionic bonds are formed with the gain and loss of electrons. Okay? So remember, just like we said with the covalent bonds, how those columns in the middle, we're going to form those covalent bonds. We can go to the outsides of the periodic table, like columns 1 and 2 and column 7, and we're going to see this is where we see a number of our ionic bonds being formed. Ionic bonds are going to be formed mostly in inorganic elements. Covalent bonds, hydrogen bonds, those are going to be found mostly in our organic molecules. Ionic bonds mostly in inorganic molecules. So let's go over here to column 1 and let's look here at sodium. Okay? Sodium is in row 3. So I have 3 orbitals here. And it is in column 1. So because I've got 3 orbitals, let's fill those in. My first one I have 2. My second one I have 8. My third one, my valence shell, because I am in column 1, I have 1 valence electron. Now, in order for sodium to fulfill that octet rule and fill this outer orbital, it either needs to gain 7 electrons or lose 1. Now, it's going to be far easier for sodium to get rid of this 1 than to gain 7. So, let me get my eraser here. And let's lose this 1 electron. If I lose this electron out here, that means that I have no orbital. And so if we look here now at our outermost orbital, it has 8 electrons in it, and this now is full and fulfills that octet rule. But sodium has 11 protons. Because it has 11 protons, in its uncharged state, it has 11 electrons. But we've gotten rid of one of those electrons. It's out here waiting to be picked up. So here we have 11 protons, but I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons, meaning that I have 1 more positive charge than I do negative charges. So sodium now becomes sodium plus, and this is what we call an ion. Because it's charged, it is no longer an atom, but an ion. And because it's positively charged, we call this a cation. I remember it's a positively charged because I always think of this T here in the middle as a plus sign, and that reminds me that a cation is positively charged. Now we can't leave this electron sitting out here by itself, so we need to find a place for it to go. And what we will do is we will move to the other side of the periodic table, and let's go look at column 7. And in column 7 we have this atom called chlorine. Okay? Chlorine is also in row 3. So that tells me that I've got 3 orbitals. But it has 7 valence electrons. So I now have 1, 2, 3, 4, 5, 6, 7. Okay? So chlorine would love to have 8, so it either needs to get 1 or give away 7. And again, it's going to be far easier to gain 1 than to give away 7. Let's go ahead and fill in our other orbitals here. Again, row 1, we have 2, orbital 2, we have 8, and orbital 3, we have 7 based on our placement on the periodic table. So because we want to fill this, chlorine is very willing to pick up this electron that's sitting out here and bring it into its own orbital. And now our orbital is filled. We have our valence shell with 8 electrons in it. Here again, chlorine has 17 protons. So we've got 17 protons plus 18 electrons. That means we have 1 more minus charge than we do plus charge. So chlorine becomes negatively charged, and again, it is no longer an atom, but an ion, and because it's negatively charged, it is called an anion. Okay? And we all learned in elementary school that like charges repel and opposite charges attract. So what will happen, because we have a positive charge and a negative charge, we're going to form an electromagnetic attraction between chlorine and sodium to produce sodium chloride. So this bond is much weaker than a covalent bond, but it still holds these together. Remember, this is an attraction and there is no sharing between electrons. The next video we will be talking about are the hydrogen bonds. So move on to the next video and you will get the full conversation on covalent, ionic, and hydrogen bonding.